Everyone, so let us solve today's problem of the day, that is Pythagorean triplet. Let us go through the problem first. Given an array of n integers, write a function that returns true if there is a triplet from the array that satisfies a square plus b square equal to c square, otherwise return a false. So what is the question stating is that we have an array of elements, okay, and in that particular elements we need to check if it has a Pythagorean triplet, wherein we should have three numbers in such a way that sum of square of two numbers should be equal to the square of the third number, right? So for example, if we have 3, 2, 4, 6, 5 as input, then we have three numbers in this particular array, that is 3, 4 and 5, that forms a Pythagorean triplet, because 3 square plus 4 square is 9 plus 16, which is equal to 25. Indeed it is a 5 square, right? So there can be multiple ways of solving this particular question. So going from the very brute force approach, what we can do is, since we need to access three elements in this particular array, we can run three loops, right? And it should have different indexes. So this will be the code for n cube solution or the brute force solution, wherein we will run three loops I, j, and k pointers, right? And basically at every instance, I am considering three elements as my a, b, and c, and I will find their squares. And at, at the end, what we can just check is we can have the combination of triplets which can be formed by ABC, the current ABC that we have. And if any of them is resulting as the sum of the other two, then we can return a true, else we can return a false, right? So obviously the time complexity of this particular code will be O of n cube. Why n cube? Because we are using three loops, okay? So we have to optimize this solution. So every time whenever there is a question of optimizing a array solution, right, whenever we have an array of elements or a linear data structure solution, if we have to optimize it, we should always think of algorithms like two pointers, binary search, or if we are allowed to use an extra space, we can use hash map or set, etc., right? So in this particular question, we can also solve this question using a hash map. So what we can do is we can store the square of all the elements in a hash map, which is mapped to the particular element, and we can run two loops, two for loops, wherein will be considering a and b at every instance, and for both those numbers we can just check if c square is present in my hash map or not. All right, so again the time complexity would be O of n square, but we have to optimize it further, right? So if you have solved problems like two sum or three sum, right, in that we use the concept of two pointers, okay? So wherein we consider an target element, like a target element, and we take a search space, okay? We take a search space wherein we use the concept of two pointers approach to find if that particular target element is or that particular condition is satisfied or not. So in here we will be using the same concept. First we will go and sort the array and then reverse it. So why sorting and reversing, I'll be telling it in the later part. So we will sort it and reverse it, so that we for every instance that I'm considering, I know that my search space towards my left is having all the lesser values than the ith value, right? So what is the approach is that at every instance, the particular ith element I will be considering as my c, right? And I need to find a and b in to form the triplet, right? So what we'll be doing is at every instance I will consider that particular element as c, and I will find my a and b towards the left. Okay, so why towards the left? Because since c square should be equal to a square plus b square, right? So obviously, when we want to form a number, right, when we want to form a number by adding two other numbers, so these two numbers should be less than the third number, right? These two numbers should be less than the third number. So to follow that concept, we are sorting and reversing the array. In why? Because I should be sure enough that at ith index I know that all the elements towards my left are smaller than my current element, right? So we'll be going through the code so that you understand it in a better way, right? So this will be the code. First we will sort it. Okay, we will sort the array and then reverse the array so that we get the sorting in decreasing order. Okay, at every instance I will consider the ith element as my c variable or the target variable. L and R are two pointers that I'm taking. So basically, if we are at 6, I am taking L at 5, that is I plus 1, and R at 2, that is N minus 1. Okay, so that is what two pointers we are taking, and a target variable. So what is a target variable? That is array of I into array of I. So why the square of that particular element? Because c square is the target variable which we are currently finding, and c is our ith integer. Okay, and this is the search we are doing using two pointers. So while L is less than R, we can take the sum value as the square sum of square of L and R. Basically, I'm squaring the 5 and 2 numbers and adding both of them, so that is stored in my sum. Okay, so if sum is greater than target, then L plus plus. So what is this condition means is that when my sum is greater than my target element, so obviously I have to reduce my sum in order to meet the target element, right? Basically what I'm saying is, whenever we have a sum or a number which is greater than my target number, so obviously I have to reduce some amount of numbers from it. Okay, so to reduce it, I will take out the bigger element from my particular search space, right, or the sum value. So that is why I will do L plus plus. That is, I incrementing the L pointer to its next index. So that is what we'll be doing. If my sum is greater than target, I will do L plus plus. Else, if sum is less than target, right? So if the current sum is less than target value, then obviously I have to add some more elements to it. So that is why we will be removing the lower particles or the lower elements from it, that is at the end, in order to get a higher element to achieve the target, right? Else, if sum is equal to target, we can just return true. And this condition I have applied for checking if there are duplicates or not, in order to ignore the duplicates, at the end of which we can just return false, that till now we have not got this true condition. So I hope you're clear with this particular question. Thank you.